Hi class. So last time we discussed about the computation ng base shear using the NSCP code. After getting yung base shear, we distributed the base shear to the rest ng framing ng ating building. So if you can recall, yung ating structure, so Hi class. So last meeting, we discussed about the computation ng base shear using the NSCP code. After getting the base shear, dinistribute natin siya sa kada level ng ating structure or ng frame. Because each level, nandun yung resistance ng structure in terms of yung mga beams. So, if we recall yung example natin last time, it is a 15-story building. So, kunwari ito yung floor levels niya, which is 15 and the roof deck. We computed yung base shear and we put that base shear sa, of course, base ng building. After nun, nilagay natin or some part of the base shear we took out and automatically passed sa roof deck or yung topmost ng frame mo. We call that yung FT. And then, yung natira dun sa base shear, we distributed sa kada floor ng building. So, dyan. Also, sa rooftop din. So, meron na tayong lateral at each floor. At each floor kasi nandun yung resistance ng building, which are yung beam. So, ibig sabihin itong lateral force na to, papasok dun sa frame natin, papasok yan sa beam, i-absorb ng beam, and then in turn, si beam, ipapasa niya yan sa column. And then, sa next lower floor, may papasok na namang lateral force, papasok yan sa beam as axial ng beam, axial force ng beam, and then ipapasa din yan ng beam sa column na nagsusupport sa kanya. Additive yung lateral shear dun sa taas. So, dalawang lateral shear na ang kine-carry ng column na to. So, next lower floor, may lateral na naman papasok sa beam as axial at ipapasa ni beam sa column. So, tatlo na yung i-carry ng column dito. And then, sa next lower floor, may lateral na naman, ipapasa ulit ni beam sa column. So, apat na yung carry na lateral force sa beam ay column na to. So, ibig sabihin, lahat ng lateral force na yan, i-absorb ng beam at ipapasa downwards, ultimately going sa support natin, which is found sa dito, sa lupa. Nandun yung support natin, yung foundation natin. Yun na nagsusupport sa ating buong building. Kaya meron tayong meron tayong design dito sa mga column dito against yung total, yung cumulative forces lateral ng upper floors. I-resist lahat yan ng mga bottom columns wherein kung i-add mo silang lahat, diba, equal yan sa base shear. So, this column will resist the total base shear. So, kung makikita nyo, in equilibrium yung structure natin. Na-resist yung buong base shear. Next. So, our next step will be hanapin kung anong magiging reactions ng frame natin. Yung kada part ng frame, yung beams and columns. How much yung mag-generate na force to resist yung lateral na mga loads. So, we can do that by using yung approximate analysis of rectangular buildings against lateral loads. So, since nasa regular building structures pa lang tayo, that's why we can use this analysis for rectangular buildings. So, we have two methods under this approximate analysis. First is portal method and then yung cantilever method. So, for portal method, This is generally used for low-rise building. So step 1, we put hinges at points of inflections. So these points are the midpoints of beams and columns kung frame ang iyong structure. Then next, you cut the topmost floor and distribute the lateral load to the columns. Next, evaluate each segment. Then you can name each segment and each hinge point para ma-avoid yung confusion. So let's have an example. So for example, you have this frame. You have a lateral load na 60 kilonewton sa top. Now, let's get ano ang magiging internal forces ng kada beams and kada column dahil sa lateral load na to. Let's use portal method. Sabi ni portal method, first step is to put hinges at points of inflection. So, what are points of inflection? So, for example, meron kang frame. So, ang nang ibig sabihin kapag frame, so, ano ibig sabihin kapag frame, you have load P dito. Kapag frame, ibig sabihin, yung structure mo, fixed siya dito. Kunwari, kapag okay. So, dun muna tayo sa ano ibig sabihin kapag frame. Ibig sabihin ng frame, sa joint na to, this is a joint, this is a joint. Sa mga joint na yan, they are maintained in 90 degrees. So, bakit? Because this joint can resist vertical load, lateral or horizontal load, and also moment loads. Kaya, hindi yan mag-rotate in 90 degrees yan. Kasi nga, ganun ang frame. Yung mga joint niya, they can resist moment or yung bending or rotation. Kaya, remember, maintained ang 90 degrees sa kanila. So, another naman, ang frame na to is naka-fixed support. So, parang yung joint ng frame, itong mga to, fixed support, they can resist or they can carry vertical, horizontal forces and moment load. So, resisted din ang rotation dito. Kaya, ibig sabihin, maintained din ang ang 90 degree angle between nung column and your horizontal. So, with that definition, ano ang point of inflection? Point of inflection are yung points wherein mag-change ang direction ng deflection ng structure. So, yung deflection, ibig sabihin, if this is your frame, tas pinush mo with this load P, pinush mo siya going to the right, syempre, the frame will go to the right na pag ganon. Pero, ganyan ba magiging deflection niya or yung ano ba tawag na? Basta yung deflection niya, yung pag-change ng position niya. Syempre, hindi. Kasi, remember, kapag mag-change yan ng position, maintained pa rin ang 90 degree angles na yan. Ibig sabihin, na-push siya, pupunta siya doon, mag-move siya doon, pero diretso muna to. At this point, sa fixed point niya, diretso muna yan. Kasi maintained ang 90 degree. At some point lang, doon siya magde-deflect. Kukurba siyang down, going to the right na pag ganoon. Pero, doon sa upper part, maintained ulit itong 90 degree. So, ibig sabihin, mag-move yan dito, pero at 90 degree pa rin siya. And then, yung unbraced length ng column lang ang nag-change. Ang kumurba. So, ibig sabihin, kung ito, sa part na to, pag ganun yung kurba, dito, pag ganun, that's a point of inflection. Kasi nga, point of inflection ay nag-change ng curvature or deflection yung column mo. And then, dito naman sa beam, paano ang deflection ng beam? So, keep na 90 degree to. Dito rin, magkikeep yung 90 degree. So, pero yung unbraced length niya, yung unbraced length ang magdi-deflect na pa ganyan. Pag ganun yun, pero since maintain ang 90 degree doon, gaganyan. Left out. Gaganyan yan. So, this point is the inflection point niya. So, for frames, we can conclude na ang point of inflections ng frames are located sa midpoint ng mga member, yung midpoint ng column and beam. So, kung dito, let's apply that. Ang midpoint niya, ang mga point of inflection are yung midpoint ng columns and beams. So, to avoid confusion, let's name na silang lahat. So, this is A, B, C, D, E, and F. Then, yung point of inflections or hinge joints, 1, 2, 3, 4, ay! Next, 4. Length of column is 8 meters. Length of beam is 10 meters. 4 and 5. So, yan na yung mga point of inflections natin. So, yung inflection na yan, hinges ang nilalagay. Sabi na, step 1, hinges ang nilalagay dyan. So, ito yung point of inflection. So, hinges ang ilalagay daw natin dyan. Anong ibig sabihin kapag hinges? So, at hinges, parang yung sa strema natin or statics, kapag meron kang kunwari beam na ganyan, and you put a hinge inside niya, ang ibig sabihin ng hinge, pwede mong i-disassemble ang beam mo at that point. Hinges are point of na pwede mong i-disassemble yung structure, and also these points can carry horizontal and vertical loads. Another to take note, these forces, ipapasa mo yan dito. So, these forces are the same forces kapag nilipat mo siya sa joint na to. Pero, ibabaliktad mo yung direction. So, ito, ilagay mo siya doon. To the right na siya. At ito, ipapasa mo dito. Ito-transfer mo doon. Upward na siya. So, ganun ang definition ng mga hinge joints. So, dito sa frame natin, nilagyan natin siya ng hinge joints. Ibig sabihin, at this point, we can disassemble. And at this point, we have to get yung corresponding vertical and shear forces. Vertical and horizontal forces. So, let's do that. Next step, cut the topmost floor and distribute the lateral load to the columns. So, since isang span lang ito, so isa lang yan, ikakat natin yan sa gitna. Ikakat natin siya sa gitna. And then, i-distribute natin si lateral load sa mga columns. So, let's do that. I-cut muna natin siya and redraw muna natin siya na nakakat. Pag ikakat yan, syempre ganyan na siya. May point of inflection and then may load. So, huwag kakalimutan ng load pag transfer ka. So, anong name ng joint natin ito? 1, 2, 3, 4, 5. And then yung segment name, segment D, E, F. Then, nakat na natin siya. And then, we will pass down this 60 Newton sa kada joint. Sa kada column. So, we have 3 columns. So, paano natin siya i-distribute? So, take note, number 1, mga external columns, external most, ito, column na to and this column will take one part ng lateral load. And then, one part to. And then, yung mga internal columns for this figure, ito yung internal column, they will take 2 parts ng lateral load na to. So, kung i-distribute na natin yung 60 kN, so, ibig sabihin 60 divided by how many parts? 1, 2, 3, and 4. So, 4 parts. So, 60 divided by 4 is 15 kN. So, distribute na natin sa column na to. How many parts kukunin niya? Isa lang. So, this will receive 15 kN. And then, itong column sa gitna, internal column will receive 2 parts. So, 15 times 2, 30 kN. And then, another external column will receive 1 part. So, 1 times 15 kN is 15 kN. So, ito na yung horizontal force for this hinge joint. Now, next, na-distribute na natin yung lateral. Now, we can evaluate each segment. So, ano yung segments natin? We have segment D, E, F, and then segment A, B, C. So, drawing natin siyang hiwalay again para magets ng lahat. Medyo napansin kung medyo madaming naguguluhan or ayun. So, segment. Paano yung each segment? Yung segment is yung dinisassemble na natin yung buong structure sa mga hinge points nila. So, yan yung segment. And then, anong segment to? Segment D, E, F, A, B, C. And do not forget yung joints. So, this is joint 1, 2, 3, 4, 5. Huwag kakalimutan ilagay yung load, 60 kN. At yung na-distribute na nating horizontal force, 15 kN dito, 30. Then ito, 15. So, ayan na yung nagawa na natin yung first and second step. Now, let's evaluate each segment. Ano yung segment D? Let's isolate. Let's evaluate segment D. So, ano-ano ang given na loadings and forces sa segment D? Meron tayong 60. Nandiyan pa din ang 60 kN sa segment D. At may isa na tayong nakuhang 15. This is joint 1. This is joint 4. Ngayon, ano-ano pang forces yung missing? Meron tayong, di ba, at each hinge may vertical, may horizontal. So, dito meron na siyang isang vertical. Ang hahanapin mo na lang is at this segment D, meron ng horizontal force yung joint 1. So, wala na lang siya is vertical. Meron na siyang horizontal. So, name natin sila na FV sa point 1. This is FH sa point 1. Dito, missing ang FV point 4. And missing din ang FH sa point 4. So, ayan na. We have 3 missing loads or forces. But we have 3 equations of equilibrium. So, meaning, this is solvable. Using statics lang naman. So, this part onwards, puro statics na yan. So, pag nakumpleto mo to, nakuha mo yung tatlo, you can go to segment E or segment A para makumpleto mo yung mga vertical and horizontal forces niya. So, same dito, makukumpleto nyo. So, lipat lang kayo ng lipat. Basta don't forget yung law of action and interaction na kapag lumipat ka ng segment, ibabaliktad mo yung direction ng vertical and horizontal forces. So, let's evaluate joint D. Saan ang ano pwede mong gawin para may makuha ka ng value? So, either mag-moment ka dito sa point 4, makukuha mo agad si FV. Or pwede kang mag-summation of forces along H, since along H, ito na lang yung missing. So, let's do summation of forces muna along horizontal. Summation of forces along horizontal, 0. So, going to the right is 60. Then, to the left na yung 15. And to the left na rin yung FH4. So, equals to 0. FH4 is equal to 45 kilonewton going to the left. So, nakuha na natin to. Next, parehong missing yung summation of forces vertical. So, hindi tayo makapag-summation of forces sa vertical. Let's just do summation of forces, summation of moment at point 4. Okay. Summation of forces, moment at point 4 is equal to 0. 0 ang moment sa point 4 since hinge iyan. So, ano ang mga forces na magkakos ng moment? So, etong dalawa lang. Ito and ito. So, for FH1, which is equal to 15 kilonewton, anong moment arm? It's 4. And then, clockwise yun. Clockwise din. Since upward ang upward ang assumption nating direction ni FV1, it's also clockwise. Times yung moment arm yan na 5 equals 0. So, we can get the value of FV1 magiging equal to negative 12 kilonewton. So, ibig sabihin, mali pala yung direction na inassume natin for FV1. So, let's correct it, syempre. Bago ka mag-proceed, i-correct mo, downward siya. And then, rewrite this, rewrite mo to para hindi confusing and maitama siya downward. So, nakuha na natin dalawang forces, nakuha na to and ito na lang ang missing, si FV4, but we can use summation of forces along vertical equal to 0. Ang vertical lang naman is FV4 and FV1. Summation of forces upward si FV4. So, positive minus FV1 equals 0. So, FV4, ano ba ito? Is equal to FV1. FV1 is, anong value ni FV1? 12 kilonewton. So, yes, upward siya. FV4 is upward. So, nakumpleto na natin ang mga forces ni segment D. So, in equilibrium na siya. So, next natin i-evaluate. Pili kayo if E or segment E or segment A. Let's choose segment A. Wala ng space. Let's evaluate segment A. So, drawing natin si segment A. Bakit pala yung sulat ko? Segment A. This is segment A. and this is joint 1. Ano yung forces sa joint 1? Kailangan natin i-transfer FH1 and FV1. FH1 is 15. FH1 is 15 going to the left. So, pag nilipat natin siya dito sa segment A, going to the right na siya. 15 kilonewton. Ano yung FV1? It's 12 downward. So, pag nilipat dito, upward na si FV1 na 12. So, 4 meters ito. So, let's evaluate segment A. Summation of moment at A is equal to moment at A. Since fixed support ito, fixed support, meron yang moment. Kaya, hindi zero ang summation. It's not equal to 0 dahil may value ang moment dyan. So, ito ang tamang notation. May ibang naggaganto but no, hindi ko gustong ginaganto kasi parang erroneous. Dapat ito. Pag nag-moment ka sa fixed support, may value ang moment mo. Don't say na 0 yan. So, moment at summation of moment at A is equal to the moment at A. So, let's get yung moment at A. Ano ang force na magkakos ng moment at A? It's 15 lang. 12, wala yan kasi it passes along moment A. So, ano ang direction ni 15? Pag nag-rotate, it's clockwise. Gaganon siya. 15 times moment arm yung force. So, 60 kilonewton meters si moment A na clockwise. So, ang direction ni moment sa A is counterclockwise. Siyempre, ika-counteract niya yung moment produced ni 15 Newton. Kaya, dapat it opposes this one. Kaya, counterclockwise. Then, let's get, ito yung moment A, pag ganyan siya. And let's get summation of forces along horizontal equal to 0. So, wala na may ibang horizontal. So, the horizontal force sa point A is equal to 15 kilonewton going to the left. Also, same sa moment, ika-counteract niya ito. Kaya, baliktad din ang kanyang direction. Summation of forces along V, isa lang din naman ang vertical force. It's just 12 na upward. So, yung vertical sa A is 12 kilonewton, counteracting yung upward. So, downward siya dyan. So, just remember, supports are there. Ang purpose nila is to counteract yung mga loads. So, natapos na natin si segment A. Pwede ka nang pumunta kay segment E. So, let me just discuss yung segment E. Pero yung the rest, isusulat ko na lang pag-practicean nyo. Puro statics lang naman kasi. Kaya hindi ko na ipapakita yung buong computation hanggang segment F, B, and C. Hanggang segment, ilang yung i-discuss ko. Kasi dito ay tatlo na yung members. Pero hindi lahat i-discuss. You should know how to do statics. So, let's evaluate segment E. So, sa segment E, let's draw muna. Let's draw segment E. So, tatlo yung branches niya. Ano-ano yung joint na to? Anong hinge joint to? Maganda if ilagay natin. This is 2, 4, and 5. So, ang mga hinahanap mong forces, FH2, meron kang hinahanap na FV2. Dito, meron ka bang FH4, meron ka bang FV4. Same dito, FV5 and FH5. Ano-ano yung meron na tayo? Actually, meron tayong FH2 which is equal dito 30. Going to the left, tama bang drawing natin? Yes, going to the left. This is 30. Ano pang meron tayo? Meron tayong horizontal and vertical sa point 4. Kasi in-evaluate natin yan kanina. nung in-evaluate natin yung segment D. So, let's go to evaluation ng segment D. Ano yung FH and FV4? Ito, FV4, 12 upward. FH4 is 45 to the left. So, to the left, si FH4, pag ipapasa mo na siya sa segment, ano to, E, pabaliktarin mo yung direction. So, FH4 dito is to the right. And then, upward, yung FV4 dito, upward siya. So, pag ipapasa mo na siya kay segment E, it is downward na. Tama yung na-draw natin. Lagay natin yung values. FV4 is how much? 12. And FH4 is 45. So, ayan. Meron tayong tatlong given and then tatlong missing. So, 1, 2, 3 na missing. Solvable pa rin since we have 3 equations of equilibrium. Now, let's solve. Nung madali, summation na lang tayo ng moment sa joint 5. Summation of moment at 5 is equal to 0 dahil walang moment sa point na yan. So, ano-ano magkakos ng moment? So, madami. Tatlo. 1, 2, 1, 2, and 3. So, let's start dun sa FV4 na 12. 12 times counterclockwise. So, negative siya. Ano ang distance? 10. 5, sorry. 5 meters, 5 meters, 4 meters. So, 10. Ano pa? Ito. So, clockwise si FV2. FV2 is missing pa. Times, ano to? 5. And then, clockwise din si FH2 na 30. So, times 4 equals 0. FV2 is, kung i-compute ninyo, is equal to 0. So, nakuha na natin to. Dalawang missing na lang. We can do summation of forces along vertical. Summation of forces along vertical. Wala nang bang ibang vertical, kundi ito lang since 0 si FV2. So, ito lang ang vertical mo. Ano ba ito? Downward siya. So, negative 12 minus FV5 since assumption natin is downward din siya. So, ibig sabihin mali ang ating assumption. So, negative 12 kilonewton. Ibig sabihin, you need to correct this one. It is upward. Upward si FV5. And so, correct mo din yung nandito mo. FV5 is 12 kilonewton. What again? Upward. Remember, dapat in equilibrium lahat. So, next, summation of forces along horizontal is equal to 0. Ano-ano mong horizontal is 45 and yung 30. So, 45 is going to the right. So, positive. Minus 30 na going to the left. Minus FH5 na going to the left. Then, so, our FH5 is 15 kilonewton going to the left. So, nakompleto na natin ang mga to. So, this is 12 and this is 15. So, nakompleto na natin lahat ng forces ng mga sa segment D, A, and E. So, you can continue solving for the rest. And then, i-drawing ko na lang yung summary niya. So, sa mga quiz or exam, do not use red pen. Nagma-minus ako pag nagre-red pen kayo. Ito yung nakuha natin 50 kilonewton na distribution. Dahil external column, then internal column will get 2 parts. And then external column will only have 1 part. Kaya ayan yung distribution natin. Now, ano yung mga nakuha natin? When we evaluated segment, lagay natin yung mga segment. This is segment A. Then joint 1, 2, 3, 4, and 5. So, when we evaluated segment D, nakuha natin is downward na 12. Then, dito, upward na 12. Dito, 45. Then, nilipat natin itong dalawa sa segment E. We changed the direction. Kaya, ganyan na siya. Same dito sa joint 1. Saglit, I just want to make this clear para hindi na malito yung iba. So, nung lumipat tayo, nung ililipat natin tong dalawang force na to sa segment A, i-change din natin yung direction. So, 12 na to, upward. And then, ito, to the right na siya. So, ayan yung mga nakuha kong internal reactions ng beams and columns. And then, evaluating yung A, B, and C, kukuha nyo yung reaction ng mga support ninyo. So, this is 12, this is 15, moment na 60, ano to? 0 to, na vertical, to the left ang 30, counterclockwise ang MB, upward ang vertical dito naman sa C, to the left yung horizontal na 15, and counterclockwise pa rin na 60 kilonewton meter ang moment at C. So, yan yung buong internal forces and reactions ng structure. So, kung makikita nyo, each segment should be in equilibrium, and then each section, kunwari, kung nandito ka, kung isa section mo to, it should be in equilibrium. Then, so lahat equilibrium, pati yung buong structure should be in equilibrium. So, let's see if the whole structure is in equilibrium. So, gawin natin ang summation of forces horizontal ng structure. So, ibig sabihin, hindi kasali yung internal, no? Yung mga external and reactions lang. So, summation of horizontal forces, yung 60 na load, positive, going to the right. Then, ito, and then ito, and then ito, are equal to 0. Kapag nag-summation of forces, vertical ka, ano ang mga vertical forces? Wala kang vertical load, pero meron kang vertical reactions. Vertical reactions is ito, downward, negative 12. And then, ito ay 0, yung dito, 0. And then, upward na vertical sa point C, positive 12 equals 0. So, check na 0 nga. So, summation of moment. So, kapag nagsa-summation ng moment, kailangan mo ng reference point. So, let's use point C as the reference point. Doon tayo mag-summation ng doon tayo mag-summation ng moment, which should be it's not equal to 0, should be equal to the moment at C. What is the moment at C? 60. So, dapat pag nag-summation tayo, should be C. So, ano-ano yung mga mag-cause ng moment? Lagay na lang natin dito para kasya. Nandito yung reference point natin. C. Doon tayo magpaparotate. Ano magpaparotate? Yung 60 clockwise. So, positive 60 times ano ang height nito? 8, diba? 8. Then, ano pa? Ang mga reactions, meron tayong clockwise na moment dito and dito. Counterclockwise, so negative 60, negative 120. Ano pa ang pwedeng mag-cause ng rotation? 0 ang vertical dito, dito may value. So, magkakause yan ng rotation. Pag ganyan. About C, diba? About C. So, counterclockwise, no? Counterclockwise. So, that is 12 times. Ano yung distance niya? From C, 20. 20. So, this should be equal to moment at C, where moment at C is equal to 60 kilonewton meter. So, if you calculate that, 60 is equal to 60 kilonewton meter. So, okay naman. Yung buong structure, it is in equilibrium.